Hi everyone, this is lesson 2-6, Nonlinear Inequalities. This is video 2.6.3, and our learning target for this video will be for students to be able to solve polynomial inequalities. So you should already be familiar with solving a polynomial inequality from video 2.61 and 2.62. But what we're going to talk about in this video is solving a polynomial inequality when it has an unusual solution set. So our first example says solve x squared plus 2x plus 3 less than 0. And what we're going to do is we're going to go ahead and solve this graphically, and I'm going to identify on the graph where the function x squared plus 2x plus 3, this quadratic trinomial, where that function is less than 0. So I'm going to go ahead and graph this on Desmos. And looking at the graph on Desmos here, what we have is a function that never crosses the x-axis. And we're actually asked where this function is less than 0. So basically what we need to describe is for which x values is the function or the y-coordinate less than 0. Now, another way to think about this is we often say y equals x squared plus 2x plus 3, which is what I have graphed right here in Desmos. And if we're really looking at where that function or y is less than 0, and we are looking on this graph right here, you can see that every x value on this graph, since the entire graph exists above the x-axis, here's the x-axis here, all of these y-coordinates are positive. So what we need to say is the answer to this is never. The y-coordinate is never less than 0. So because this graph, x squared plus 2x plus 3, is never less than 0, there is no solution to this inequality. In other words, x squared plus 2x plus 3 is less than 0 has no solution. So, looks like we are done with this question, and we're going to move on to another example where we have an unusual solution set. Alright, this time we are looking at solving x squared plus 2x plus 3 greater than or equal to 0. So we have the exact same graph we had in the previous example, except for this time the solution we're looking for is to x squared plus 2x plus 3 greater than or equal to 0. In other words, we want to know where y is greater than or equal to 0 on this graph. Now, again, we said previously, since the entire function here, the entire equation, the graph of the function is above the x-axis, because here's our x-axis, that means that y-coordinates on this function are always positive. Y is always positive on this graph. Every single point has a positive y-coordinate. And since this function is always positive, and we are looking for for which x values the y-coordinate is greater than or equal to 0, the answer to this is always. The y-coordinate is always greater than or equal to 0 for this function. Therefore, the x-coordinates where the y-coordinate is 0 are negative infinity to infinity. If we write our solution in interval notation, because every x value has a y-coordinate greater than or equal to 0, we say for all x values, which that interval is negative infinity to infinity. So this is our solution to the inequality, and we can go ahead and look at another example where we have an unusual solution set. Okay, so now we're looking at a different example here. We have x squared plus 12x plus 36 is greater than 0. And here we have a quadratic that is factorable. This factors into x plus 6 times x plus 6. So we want to know where this function is greater than 0. And just by looking at the factorization here, I can tell that my 0 for this function, if I set x plus 6 equal to 0, is at negative 6. So since both of these factors here, x plus 6 and x plus 6, give me a 0 at negative 6, that tells me that we only have one 0 for this function, and that this parabola, x squared plus 12x plus 36, will touch the x-axis at negative 6 and not intersect it there. So I'm going to go ahead and graph this function. Okay, I already know that my based on the leading term test, my end behavior is going to be both up. So if I count by 2's here, I have negative 6 as my 0. I know both ends go up from that point. So my parabola is going to look something like that. Now just to reiterate how I determined that both ends here were up, because my leading term test says when my exponent is even and my lead coefficient is positive, both ends are pointed up. Now Desmos provides a little better picture than my sketch, but it confirms that we intersect the x-axis right here at negative 6, and then the graph is positive for all x values with the exception of negative 6. At negative 6, the function or y-coordinate for the function when x is negative 6 is 0. So negative 6 comma 0 is an ordered pair on the graph of the function, and we want to know where the function is greater than 0. Well, to tell you the truth, the function is greater than 0 for every x value except right here when it touches the x-axis at negative 6. So our solution to this is negative infinity to negative 6, because again at negative 6 the function is not greater than 0, and then from negative 6 to infinity the function is greater than 0. So if we look at this closely here, the function right here from negative infinity until we reach that x-intercept is greater than 0, and then once we touch that x-intercept at negative 6, we're no longer greater than 0. So we're not going to include negative 6 in our solution set because that is the only x value for which the y-coordinate is not greater than 0. And then after that x-intercept, the rest of the x values for this function provide you with a y-coordinate greater than 0. Therefore, you would say negative 6 to infinity, the function is greater than 0. Alright, let's take a look at another example with an unusual solution set. Okay, so we are looking at solving a polynomial inequality. It's the same function that we used before, different inequality. This time we're looking for x squared plus 12x plus 36 less than or equal to 0. So if we're looking at this function, we want to know where this graph, where the y-coordinate is less than or equal to 0. Well, we said in the previous example that the function was greater than 0 for all x values with the exception of negative 6, which is where the graph touches the x-axis, which means the y-coordinate is 0 there. So the only solution here to this inequality, the only location on this graph where the y-coordinate is less than 0 or equal to 0 is at the x-intercept. So the only solution to this, the only x value where the y-coordinate is less than or equal to 0 is negative 6. So we have a single solution here, only one x value, where, again, our function is less than or equal to 0. So our inequality solution then is negative 6 with brackets around it, and I used brackets rather than parentheses here because negative 6 is included in the solution set. Okay, it's time to check for your understanding. I want you to solve x squared plus 6x plus 9 less than, not less than, greater than 0. And you have 4 choices, A, B, C, or D. Go ahead and work out the inequality and choose a solution and press submit. So looking at this quadratic trinomial here, I can factor this as x plus 3 times x plus 3 greater than 0. And I know that this function here by the factors is going to have a 0 at x equals negative 3. If I set x plus 3 equal to 0, that means x is equal to negative 3. So when I look at my graph of my function, I know that we are going to just touch at negative 3. There's only one 0 here because both factors are the same, which provide me with the same 0. And I know that my end behavior is pointed up, again, because my lead term is x squared. Since my degree is even and my lead term is positive, the function opens up. So, looking at the graph of this function, I need to know where the graph is greater than 0. And if you look at the function here, the graph is greater than 0 right here from negative infinity until I reach this point right here at negative 3. Right here at this point, the graph is no longer greater than 0, but it is equal to 0. And then after I hit that point, the rest of the way, for the rest of the x values, the y coordinate is greater than 0 again. So, what we're going to say is the function is greater than 0 for all x values with the exception of negative 3. So, if you look at that, the graph is a greater than 0 for all x values except for negative 3, and the interval that provides that answer is negative infinity to negative 3 union negative 3 to infinity. Notice that they used the parentheses here because they did not want to include negative 3 in our solution set. Again, because negative 3 comma 0 is this ordered pair here where the graph touches the x-axis. So, D is our solution, and we will be done. Please make sure you ask if you have any questions.